The graph of the quadratic function has been presented in three ways. Each form has its own advantages and disadvantages. We have standard form, x-intercept form, and vertex form. If a question concerns the y-intercept, standard form is ideal. And clearly, x-intercept form and vertex form, as their names suggest, make finding certain points a breeze. Quadratics can also be represented in piecewise functions. Sketch the graph. There are two pieces. Graph each. Be careful to consider the domain restrictions. Alright, so if x equals 0, let's see what the y-intercept is here. If x equals 0, which is less than 1, 2x plus 1. And in this case, x is 0, so that would be 1. So we have a point right here. If x equals 1, that would be x minus 2 squared. So when x equals 1, that would be 1 minus 2, which is negative 1 squared, which is 1. Alright, if x is 2, that would qualify under this rule here. 2 minus 2 is 0, squared is 0. If it's 3, 3 minus 2 is 1, squared is 1. If x is 4, 4 minus 2 is 2, squared is 4. And so on. So this is a quadratic function right here that's going to be a parabola. Let me draw that again. So this parabola is going to look something like this, but this is a line. So let's go ahead and figure out this line. If x is negative 1, that would qualify in this rule. 2 times negative 1 is negative 2, plus 1 is negative 1. So that would be here. If x is negative 2, that would be negative 4 plus 1, which is negative 3, and so on. So if we draw our line that connects these dots, it would look something like this. Now, where would the open, see, we have two different values at 1 now. Where should the open circle be? Well, this rule is going to have an open circle at 1. So we're going to have an open circle right here, because when x equals 1, it will be the green graph, not the red graph. And here we have a much nicer looking picture of this graph. Write a piecewise rule. So here we see an absolute value graph, and we see the graph of x squared. So if we start out with this one here, this is a negative absolute value graph that has been shifted to the left 3 units. So the parent graph of absolute value is like this, like that. So we flipped it upside down, so we add the negative sign, and then we've moved the vertex over 3, so we'll have x plus 3, because remember it's x minus h. So if we have plus 3, we move to the left 3 units, and this is the graph for when x is less than or equal to negative 1. We know that we have the equal sign here because we have a filled in circle at x equals negative 1, whereas we have an open circle up here. So this graph is just the graph of x squared, because the vertex is at the origin, and the two next points are at negative 1, 1 and 1, 1. So this is a regular parent function x squared, and this is for when x is greater than negative 1. And there we go.